All right, this is the calculator part of the review. We could see any of these types of questions on our test tomorrow. However, I won't have one of each because that would make it too long. So make sure you come in and ask during office hours if you're having trouble with any of these. Okay, given an initial investment of $5,500, that's our principal amount, into an account that pays an annual interest rate of 2.25%. As a decimal, R is 0.0225. You divide by 100. This should be answer questions. Let's see. I don't think it's 36 to 38. You guys have extra stuff. Oh, wait. Am I missing a domain section? Sorry, I'm checking to see if yeah, after equations. Sorry. Let me do this domain part real quick. Sorry, for my video, I must have copied an old review, which I did not mean to do. Okay. Stepping back before we do calculator part, let's do these domain problems. So, okay, write the domain of each function in interval notation. So for any log, remember we can't log a negative or 0. So it doesn't matter what log base you have or natural log or whatever, you're setting the expression inside of the logarithm greater than 0 every single time because we want to make sure that this stays positive. Now, if it's just a linear expression like this, I can just isolate x. So I'm going to subtract 5, divide by 3, and in interval notation, that's negative 5/3 to infinity. So that's my domain. For this one, natural log of 16 minus x squared, again, we set 16 minus x squared greater than 0. And we've done this quite a few times now. It is always surprising, though. This doesn't seem to stick for some students, that if it's quadratic or rational or any polynomial besides linear, you need to use a number line to figure out when is this graph greater than 0. So first, get the critical numbers. When is 16 minus x squared actually equal to 0? And that's at plus or minus 4, right? You can factor that or use square root method. And then you're supposed to put those two numbers on a number line. Greater than 0, so open circles. Now think about, or test numbers, think about this graph, 16 minus x squared. It's a parabola that opens down, and the plus and minus 4 represent the x-intercepts. So it's a graph that looks like this. To the left, the graph is negative. In the middle, it's positive. To the right, it's negative. Or you could plug negative 5 into this, plug 0 into this, plug 5 into this, and see how your numbers are coming out. We want the positive section. So my domain is between negative 4 and 4. And same idea for the last one. Take the expression that's inside of the log, set it greater than 0. And then we do not multiply the x plus 4 over because you'll lose a solution set. Instead, you get your critical numbers from the x-intercept and the vertical asymptote. Those go on a number line. They're both open circles because one's a vertical asymptote and one is just, we're looking at greater than 0. I don't really want to graph this one. I would rather plug in numbers. So if I plug in negative 5, I get negative 7 on top. I get negative 1 on the bottom. That divides out to positive 7. If I plug in 0, I get negative 2 over 4. That's negative. If I plug in 3, I get 1 over 7. Positive. We want the positives. So this domain is negative infinity to negative 4 and 2 to infinity. Okay, so on to the next part. Now my numbers are going to be off because, again, my blank review is an old version, but the problems are all the same. So, okay, so let's take a look at this. We had our principal, we had our interest rate. We are rounding dollar amounts to the nearest cent, which is 2 decimal places, and then any time answers or any other answers that are not dollar amounts to the nearest thousandth. Remember, on the AP test, if you don't round the way they tell you to round, then you're not getting credit. So this problem says find the balance in the account after 15 years, so that's T. If the interest is compounded semi-annually, that's when n equals 2. Quarterly, that's 4 times a year. Monthly is 12 times a year. Continuously is the PERT formula. All right, so our first one is the account balance is equal to 5,500 times 1 plus R over n to the n times t. It's not RT for this one, it's NT. And I'm going to enter that into my calculator and round this to 2 places. You can type it in exactly as you see it. You don't need a bunch of extra parentheses. All right. So my first answer is 7,693.41. All right. Now the second one, all we're changing is quarterly. So the balance is still 5,500 times 1 plus r. Now it's over 4 to the 4 times 15. And you can just either press second enter or get this line again, change the 2 to a 4 in both places. And now we're at 7,700.63. Make sure you label with a $sign. Monthly, still starting with 5,500. 1 plus 0.0225 divided by 12 to the 12 times 15. Now, if you can retype it, or remember, you do need to use the insert feature. Like, I want to insert a digit here to make it 12. And same thing down here. Otherwise, it'll just kind of write over stuff. So insert a 1 and then arrow off to make it stop doing the insert and just be able to overwrite that. 7,705.48. And then the continuous formula does not involve an n, because what would n be if it's continuous? You'd be approaching, n would approach infinity. So instead, this is a equals p, which is still 5,500, times e, which is our irrational number, to the r t. Right, so 5,500 times e to the 0.0225 times 15. 7,707.92. You can see all of my answers are sort of in the same ballpark, because we're not drastically changing things, just how many times we collect interest. And the more times you collect interest, obviously, the more times a year you collect interest, the more money you're going to have. So it makes sense. If your numbers are wildly different, though, when you're doing this, you'll know that there's a typo somewhere. If the interest in the account is compounded continuously, how long will it take for the initial investment to double? Now, I did give you an initial investment amount, but let's just pretend you weren't given one. We've done this before. So say we don't know what the principal amount is. So we would be using P e to the 0.0225 t. If we're just doubling the amount we started with, you would begin by saying, well, that equals 2 times p. And then the first step is to divide by p. So the original amount really doesn't matter. You can go ahead and double 5,500 to 11,000. But then if you divide 11,000 by 5,500, you're just going to get back here to 2 equals e to the 0.0225 t. So you could even start there if you want for your first line. And then to solve this, I think solving algebraically is probably fastest. I would just natural log both sides. When you natural log the e, that cancels out. So it's going to be natural log of 2 equals 0.0225 t. And then we divide by 0.0225. So let's see what this is. So natural log of 2, close parentheses, divided by 0.0225. To 3 places, because we're no longer talking about money, 30.807. 30.807. T is measured in years in the compound interest formula. You could solve by graphing as well. Set 2 into y1 and e to the 0.0225 t into y2 and find the intersection point as well. If the interest is compounded quarterly, how long will it take for the balance of the account to reach 8,000? So this time I'm saying, okay, 8,000 equals, we're still talking about the initial investment of 5,500 compounded quarterly. So I need to do 1 plus 0.0225 over 4 to the 4t. So how do we solve an equation like this? Again, you could just graph. Let me just show you that. Clear all this out. Okay. So you could type in, it doesn't matter which goes in which. 8,000 is going in one line. 5,500 times 1 plus 0.0225 over 4 raised to the 4x power. Now, I do have to think about the window here. So we were doubling our money. So doubling our money would have put us at 11,000, and I'm only trying to get 8,000. So I know that it's going to be something less than 30 years. So I'm just going to guess at my window and just go ahead and set the window from like 0 to 30. And then I'll zoom fit. As long as you can see the intersection point, you're good, and the calculator will find it for you. So this is 699 would round up to 700. So what was that again? So 16.700. So time 16.700 years. If you do not solve by graphing, then here's what you have to do. So you would divide. I'm going to divide by 100. It'd be 80 over 55, which we could divide out if we want to, but I'm just going to leave it like that. And then let's go ahead and see what is, let me split screen here. What is this as a decimal, so I can stop writing it like that? So 1 plus 0.0225 over 4. Now, I'm going to use this full decimal. Do not round it because this is not a final answer. So you never want to round anything as you're going along. I just want to be able to write this as 1.005625 to the 4t. Okay, then what are we going to do algebraically? So I want to get rid of this base number. So your calculator, if it has log base, you can use this log base option. You can say, I'm going to log base 1.005625, the 80 over 55. And that will be equal to 4t because I just log based that side the same way. So choose log base and type in that number. Again, not rounded. And of 80 over 55. I didn't bother typing that in because if it doesn't simplify nicely, then I don't care what it is. And then 4t is equal to this. So then we're going to divide by 4. So divided by 4. And I get the same answer, right? So same thing. So it does not matter to me how you do it. You're not getting more points for solving algebraically versus graphing. It does not matter to me. I would probably just choose graphing because it seems faster. But if you have trouble with the windows, or if you try graphing and you're not getting the intersection right away, then you can fall back on algebraic. What about this one? The function f of x equals 20 times 0.975 to the x models the percentage of surface sunlight, f of x. So f of x is the percent of sunlight that reaches a depth of x feet. So x is the depth beneath the surface of the ocean. What percentage of surface sunlight reaches a depth of 80 feet? So they're giving us the x. They're asking us to find y. So f of 50. So that would be just plugging 50 into this. And because the next question is asking me to solve, I'm going to type this into my y1. Clear out the old stuff. And just do everything from here. So 0.975, raise it to the, I don't want to raise it to the 50th power if I'm doing it here. I want to raise it to the x power. And then on my home screen, I can say, okay, what's y1 of 50? You can also just type this in, what I wrote down on your home screen. That's fine. And then what is f measured in? It's the percent. So this is 5.640%. That makes sense because if you plug in 0, you get 20. So that means 20% is at a depth of 0. And then below that, this is a decay model. So the further down you go, the less sunlight that comes through. That makes sense. So I'm going to label that percent sunlight. Okay, and then the second question says, at what depth is 1% of the surface sunlight visible? So you're setting your equation equal to 1. And trying to solve for x. And again, I would just use the calculator to solve for this. So it's already in my y equals. I'm going to put a 1 down here. And then use use what you have. We had to type in 50 just to get it down to 5%. So I'm going to use my window and say, all right, let's start at 50 then and go out to, I don't know, 100 and see if that's good enough. So let's zoom fit. So 100 is not far out enough because see how I don't see the intersection point? So you can bump your window even farther. Maybe I go to 200 and then I'm going to, you can zoom fit again. There we go. So that's good. I can find the intersection point. So 118.325. 118.325. X is measured in feet. That's how far down you'd have to go for only 1% of the surface sunlight to be visible. What if you want to do it algebraically? So same steps as before. Isolate the exponential piece, so divide by 20. You're going to log base 0.975 both sides, and that's going to equal x. So math log base. If you, oops, not on this screen. If you don't have the log base feature, you can borrow one of my calculators, or you could still do this by saying, I'm going to natural log both sides, pull the x out in front, divide by 0.975, the way we do with those equations that you can't just log base on our non-calculator ones. So see how I get the same answer. Okay. This one, P of X is this log function, models the percentage of students who can recall important features of a classroom lecture as a function of time, where X represents the number of days since the lecture. How many days will it take for only 50% of the students to recall the information? So again, even though they give us 50%, P is the percentage, so you're setting the equation equal to 50. Or if you think about plugging numbers in here, like if you plug in 1, you're going to get 95, so that means 95%. So set this equal to 50. And again, you can solve by graphing. We'll have to kind of guess at the window because we don't have much information to go off of. And then you can log base in here too. So log base 2 of x. So that matters. You can't just type in log because that's base 10. And then I don't know, what should the window be? Well, 0 for sure. And then let's give students 2 weeks to see what happens to get down to 50%. It probably won't take that long. Zoom fit. There we go. So find the intersection points. 2.828. So, it only takes between 2 and 3 days. What was that? 2.828 days for students to only retain about 50% of those important features. All right. Half-life for this problem. So I know I didn't give you the half-life formula on here. The half-life formula makes sense because think about this. You start with a certain amount. Oops, not equals. You start with a certain amount. You're supposed to get half of that amount after this number of years. So you're multiplying it by 1/2, and then you raise it to the t over 7,340 years. Why is this the half-life formula? Because when you plug in the half-life, then you're taking exactly 1/2 of what you started with, right? So that makes sense. What are we trying to get to? We're trying to figure out how long will it take the sample to decay to 20% of its original amount. So kind of like the doubling problem. Set this equal to 20% of what you started with. So the P does not really matter. It's really just 0.2 equals 1/2 to the t over 7,340 power. I can solve by graphing. Now remember, half-life problems, if you're going to solve by graphing, half-life is usually takes quite a bit to get out there, right? So I don't think I need these parentheses, but I just like using them. So if you're going to guess, okay, we're trying to get to 20%. It takes 7,000 years just to get to 50%, right? So let's set our window at I'm going to start at 8,000 because again, 7,300 just to get to 50% half-life. And maybe we'll bump this out to like 20,000 because our previous half-life problems have been in the teens, in the thousands. So zoom, fit. There we go. So second, trace, intersect, boom, boom, boom. Yeah, so my answer is 17,000. Let me split here so I don't have to go back and forth. So this comes out to 17,042.952 years. That's how long it would take to get down to 20%. And again, what if you're solving algebraically? Well, there's nothing to isolate here. So you would say, I'm going to log base 1/2 both sides. That leaves me with t divided by 7,340. And then here you need to multiply this time. Multiply that over to isolate t. So let's just check that math to make sure it works. 7,340 multiplied by log base. Base is 0.5 and decimal in there is 0.2. Yep, I get the same answer. Okay, a logistic function. The logistic growth function, this describes the number of people who have become ill with influenza 2 weeks after its initial outbreak. How many people became ill with the flu when the epidemic began? So initial amount, beginning is always t equals 0. So this is asking you to compute f of 0. Now you can either do it on your home screen. What is this? 100,000 over 1 plus 5,000. Or remember, when you plug in 0, that's really just 1. So this is really just saying what's 100,000. Make sure I type that in right. 5 zeros there. 100,000 divided by 5,001. So it's 19.996. Round to the nearest person, so about 20 people. 20 people. So we started with 20 sick people. How many are we going to get after the 4th week? So find f of 4. Now, the next one is solving again. So if you're going to solve by graphing, maybe it's worth your time to plug this into your y equals. So I'm going to go ahead and do that. Remember, we have alpha y equals, which calls up the fraction thing, which is kind of nice to use. Not required, but nice. And this is 1 plus 5,000. Be careful here. It's e to the negative t, so negative x. So if you get this into your y equals, then you can just say, what's y1 of 4? 1,080.168. Again, round to the nearest person, so 1,080 people. That's a lot of people sick. How many weeks will it take for 10,000 people to become ill? So again, use your answers that you've previously used. We plugged in 4. We were only at 1,080. So this is saying set your equation equal to 10,000. So here I am doing that. And this is the work I'd like you to show if you are just solving by graphing. So I go back to my y equals. I type in 10,000. What's my window going to be? So 0 to, I don't know, will it take, this is probably going to grow quickly. Will it take 10 weeks? We can try that. Zoom fit. Oh, there we go. So that was good enough. So find the intersection. 6.320. So t is about 6.320. I'm going to leave that decimal there because we're talking about weeks. If you want to solve this one algebraically, you need to get this out of the denominator, multiply it over to this side, and turn around. Don't distribute the 10,000. Turn around and divide it over here. So what's 100,000 divided by 10,000? So 100, so the thousands can come off. 100 divided by 10 is 10. Isolate e. Subtract 1, you get 9. Divide by 5,000. Natural log both sides. And get rid of that negative. See if that comes out the same. So negative natural log of 9 over 5,000. Yep, same answer. Okay, last couple of problems. So I think we had a regression, one or two problems in our textbook assignment, but it's been a while. Maybe an AP Classroom, I can't remember. The data below shows the amount of savings needed for healthcare expenses during retirement compared to the age at death. Using an exponential regression, so it tells you what to do. Exponential regression, find the amount of savings needed for a person whose age at death is 87. So we need to get a regression model and then set it equal to 87. So let's begin by typing this data into our calculator. All right, so the ages at death are 80 to 100, and we're going by 5. So stat, edit, 80, 85. So type these in. And then the savings needed, I'm going to type in the full amounts. You could probably cut the thousands off and just pay attention to what you're setting your equation to if you do that. So I'm keeping the thousands in here. All right. And then when I solve my equation, or no, I'm not solving my equation. When I type in my equation, I'm just plugging in 87. So it'll give me the answer in thousands already. All right, so how do we do exponential regression? So any regression is in stat, calc, and then toward the bottom of our list is exponential regression. It's option 0. Should say L1 and L2. If it doesn't, you can fix that by doing second 1, second 2. Store your regression equation because you don't want to have to type out all the decimals. You want to let the calculator do that for you. So alpha trace y1 calculates. Now I am going to write this down. So when you write your equation, it should be the full equation, no decimals. So 2.896.716118. Did I say no decimals? I meant no rounding decimals. Times b, which is 1.056093202. Worst case scenario, you type this out on your home screen and you raise it to the 87th power. I'm just going to, because this is stored in my y equals, I'm just going to say, tell me what y1 of 87 is. Was it 87? Yeah. So how much savings would this person need? They would need about, just for healthcare stuff, 334,196.15. Does that answer seem reasonable? Yes, because 85 was 307,000 and 90 was 409,000, and I got something in between there. So that is a good sign. All right, last problem. This is a no calculator one, and I wanted to change this. After seeing our AP test from last year and the practice test, they use this exponential model instead of the a times e to the bx. So let's do it like this. So an experimental population of mosquitoes is growing exponentially like this. The initial population of mosquitoes was 100, so 0, 100. When time was 0, population was 100. After 4 days, there were 165 mosquitoes. We did this with flies in our notes packet, so if you're not sure, you can also look back at that. Show the work to find the coefficients for A and B without the use of a calculator. So remember, this was from the free response question number 2, where part A was just like set up your two equations. So plug these 2 points in, see what you're working with. So y is 100, and that's A times B to the 0 power. And then the other equation is 165 equals A times B to the 4th power. And then part 2 of that question on our free response was like, okay, so go ahead and solve. Now this one's easy because b to the 0 is just 1. So a equals 100. So we know that. Once we know that, we can go this way and say, well, if I know a is 100, now I have 165 equals 100 times b to the 4th. I want to solve for b, so I'm going to divide by 100. So that's just 1.65. And then I need to 4th root both sides. Technically plus or minus, but we're talking about population growth, so I want b to be positive. And how do I do a 4th root in my calculator? So there is a spot, but remember, 4th root is just to the 1/4 power. So that's the way I would do it. If you really want to find fourth root, it's in the math menu, and you should have x root here, and you can type in a little 4. But, we do this with exponent rules all the time. Sometimes we forget about how we can use those in our calculator. So B is about 1.133. If I remember the AP questions correctly, they do want decimal approximations for these numbers. All right, that finishes up the calculator part. So again, you can either solve by graphing or solve using log base in your calculator. That part is just your own preference. You should have time to do either of the two.